Stop. Before you watch another plane take off, imagine this. What if I told you that the massive aircraft flying above your head is powered by something as simple as a balloon? Sounds unbelievable, right? But today, you're about to discover the hidden science behind jet engines, explained in the simplest, most engaging way possible. And trust me, once you understand this, you'll never look at airplanes the same way again. The secret behind flight. Let's start with a simple idea. Have you ever blown up a balloon and then let it go? It zooms around the room wildly. Why? Because of a powerful rule in physics called the Newton's third law of motion. Every action has an equal and opposite reaction. When air rushes out of the balloon, it pushes the balloon forward. Now imagine doing the same thing, but with fire, pressure, and extreme speed. That's exactly how a jet engine works. Turning air into power. A jet engine doesn't pull the aircraft forward. It pushes it forward using a powerful stream of air shooting out the back, called thrust. And here's the key. The faster the air shoots out, the stronger the push. So the entire job of a jet engine is simple. Create extremely fast-moving air. But how? Step 1: Air intake. Everything begins with air. As the aircraft moves, or even stands still, the engine pulls in huge amounts of air from the front. But normal air isn't enough. It needs to be compressed and heated. Step 2: Compression. The power buildup. Inside the engine, there are rotating blades called compressors. These blades spin at incredible speeds and squeeze the air, increase its pressure, raise its temperature. Think of it like packing more and more air into a tight space. The energy builds up, ready to explode. Step 3: Combustion, where the magic happens. Now comes the most exciting part. Fuel is injected into this high-pressure air in a chamber called the combustion chamber. The fuel is sprayed as a fine mist and ignited. Collision. Boom. A powerful explosion occurs, but in a controlled way. This creates extremely hot gases, rapid expansion, massive energy release. This is the heart of the jet engine. Step 4: Turbine, powering the engine itself. Now here's something clever. The hot, fast-moving gases don't just escape. They pass through a turbine, a set of special blades shaped like wings. As the gases hit these blades, they spin the turbine. And guess what? The turbine is connected to the compressor. So the engine uses its own energy to keep itself running. It's like a self-sustaining cycle. Step 5: Exhaust thrust. After powering the turbine, the remaining gases blast out of the back of the engine at extremely high speed. And this creates thrust. The faster the exhaust, the more powerful the push. That's what moves the aircraft forward through the sky. The genius design. To make the exhaust even faster, the engine narrows toward the back. This increases the speed of the outgoing gases, like putting your thumb over a hose to make water spray faster. Modern upgrade: multi-spool engines. Modern jet engines are even more advanced. Instead of one compressor and turbine, they use multiple sets called spools. Inner spool spins faster. Outer spool spins slower. This design improves efficiency, reduces stress on parts, increases engine life. Some engines even use 3 spools. The problem with old engines. Earlier jet engines, called turbojets, had a big issue. They were extremely loud. They used more fuel. That's where innovation stepped in. The game changer: turbofan engines. Modern airplanes mostly use turbofan engines. These engines add a huge fan at the front. Here's what makes them special. More airflow. The fan pulls in a massive amount of air. Bypass air. A large portion of this air bypasses the engine core. Extra thrust. This bypassed air produces most of the thrust. Quieter and more efficient. Turbofan engines solve 2 major problems. Noise reduction. The cooler bypass air mixes with hot exhaust, reducing noise significantly. Fuel efficiency. They produce more thrust using less fuel. That's why almost every commercial aircraft today uses them. Final thought. So next time you see a plane soaring across the sky, remember this. It's not just metal and fuel. It's a perfect combination of physics, engineering, precision, and a simple principle discovered centuries ago. Push air backward, and you move forward. And now I'll ask you something. The next time you fly and hear that engine roar, will you still hear noise? Or will you hear the sound of pure science in motion?